Geometric Technology has grown today as a Central India's largest mechanical design service provider company because of his vision and skill. Geometric Technologies has reputed client in USA, Europe, and in India. He has published paper on implementation of CAD/CAM in the Indian industries in University of Pune in the year 1998 and was appreciated. He has been placed first position among 100 entrepreneurs in the MSME success story published by Government of India in 2018. This is the brief introduction about our esteemed speaker, Sahul Chivande sir. Now I would like to request sir to share your thought with us.
Okay. Thank you, Dr. Saroj Kumar sir. Thank you very much. Good afternoon all. Myself Sahul Chivande from Geometric Technologies. My today's topic is Indianization of OEM equipment in industries by reverse engineering. So why I choose the topic? Because I have the vast experience. My company is working for last 24 years in Indian industries, mostly in field of reverse engineering. So I will brief you one by one. So what is mean by OEM in industries? See, OEM is everybody knows that definition. The OEM is the original equipment manufacturer. In most of industries in India, the plants like steel, cement, power, aluminum, that machines and the systems are deployed from the Europe, USA, China, etc. Because very few industries, small industries, being implemented by the Indian industries, but most of the plants in India are set up by the overseas clients. So, particularly talking about the steel industry, I choose topic related to steel. The OEM equipment in steel plant refer to the various specialized machines and components. Machines means the lines, like we have the mills, we have the bar mills. So that lines, that production lines are set up by the OEMs. Words used by another company that is just like JSPL or SAIL, etc. are the cement plants that use manufacturing processes to manufacture the product. So the components might include blast furnaces, means departments, I say departments. Blast furnaces contain casters, rolling mills. Then there are many other equipments like, so these are the lines are implemented or brought from the overseas industries. So OEM are okay. So what is reverse engineering? So see, the reverse engineering is nothing but the process of generating the computer-aided design from the spare parts, whose documentation we don't have, for from existing physical parts. It also enables the reconstruction of the object by capturing the component's physical dimensions and geometrical features. The main aim of reverse engineering is to reduce the manufacturing cost, the new product, making it competitive in the market. So this is the basic terms of reverse engineering. Now, need of reverse engineering. Why we need a reverse engineering? As I told earlier that most of the industries in India have uses the machines and lines to manufacture their products from the overseas. So manufacturing of components after discussion of existing product lines, we've seen that in many cases, the manufacturing processes are the lines which are existing from last 40 to more than 40 years in India, and still they are running. So in this case, there are a lot of spares and machines involved in the line to manufacturing this, just say steel. So in the case of maintenance, when we find that some of the components get wear out, and we need to arrange that components for running the line, we find that when the product line is discontinued in overseas, we have a very scarcity of finding the right products, right spares. So in that case, the reverse engineering play a key role in developing that spares with help of reverse engineering so that the product get developed in India. Sometimes redesign the existing design which lacks adequate product data and documentation. We find that when we modernize some of the lines in India, so we have to redesign the existing products. And for that, we have to take a reference. And to take a reference, we have to reverse engineering it. Generation of cheaper alternative products as a sustainable for monopoly products. Being the OEM, they have their products have the very high cost. So to make in competitive age, to be sustained in the competitive age, we have to go for alternate products, means cheaper products. And for that, we have to make it reverse engineered and make the manufacturing drive in a proper way so that we can develop it in India. The way of reverse engineering. In traditional times, in the a few years back, we will depend upon the routine measuring instruments like vernier calipers, micrometer, thread gauges, sort of equipments to capture the critical dimensions of the spare parts. You can see in my slide, I have mentioned one of the sketch that draftsman goes to the spare with the spare parts with measuring instrument, and he will sketch the dimensions, required dimensions. See another example. So this is the one of the casing of the gearbox. It just snaps it. So draftsman take it the measurements with the help of verniers, screw gauges, sort of measuring instruments, and then from his sketches he has to go for the drafting the final product. Now the things have changed now. In the recent trades, CMM machines and 3D scanners. It may be the handy, fixed, or arm type of scanners. There are a lot of 3D scanners available in India. Some of them are handy scanners, some of them are the fixed bed scanner, and some of the arm scanners, which can move with the 7 axis. It depends. Everyone has the pros and cons. Then in the recent trend, we have the material testing equipment, maybe destructive techniques, and latest non-destructive techniques are also introduced in India, like laser gun. We can test the material also. Then 3D modeling of high-end software for using the 3D scan data. If required, we find that the component is critical and we have to test it uh, in the computer. We have a CFD and CA software. If required, we can do that analysis also. So I will show you the one to two video of 3D scanning. So this is the gear and shaft arrangement. We are scanning it for the Hindalco. This is the arm type scanner of hexagon make. One more video I will show you. Now, process of reverse engineering using 3D scanning. As in just my last video, you find that the one of component of choke, which have image in left side, is the actual spare. Then second one is the scan image. The scan is nothing but the millions of points in the name of point cloud data. So point cloud data, we have all the informations. When we have to go for the reverse engineering means development of drawings or 3D modeling, we have to extract the dimension of point cloud data. It's not facilitated. So from point cloud data, we have to make a STL image. From STL image, we can call it in any kind CAD softwares like SolidWorks. You are usually using SolidWorks, CATIA, AutoCAD, NX, and we from that STL image we can recreate the CAD model. And from that CAD model, we go for the drafting because point cloud and STL don't have permissions to extract the views. So this is the in general process of reverse engineering using 3D scanning. So uh, we can compare reverse engineering using manual methods, traditional method, and with the help of 3D scanning, we find that if anybody take the sketch, you might know that the taking sketch or handling measuring instrument itself is a very varying reading we can find. So any person who have more experience can accurately take the dimensions, but if a less experienced person may can miss the sum of dimensions or take the error in taking dimensions. If the dimensions get wrong or we missed some major dimensions, then it's very difficult for us to make the proper manufacturing drawing. Whereas in the case of latest 3D scanning, your physical part is almost at our computer. If, what happens in industries, because the production lines are up and running, whenever they have a maintenance schedules, at them they can take up the parts for reverse engineering or maintenance purpose. In a very short duration of time, we have to make it take the manual measurements or 3D scanning. But in manual measurement, if you miss the sum of dimensions, then we have to again wait for the another maintenance schedule. But in the case of the 3D scanning, once we have a scan data, we will no need to worry about the missing dimensions. At any time, we can take any dimensions from the scan data. So that is the advantage of the 3D scanning. Apart from that, the things will be move faster. Once we have a 3D scan data, we can make the accurate CAD model, 3D model, then we can easily place the views. But in the case of the manual measurements and with the help of the low end using low end softwares, MS softwares, it's very difficult to draw the actual projections. There might be something error happen. So this is the comparison between the taking measurement with the help of manually or with the help of 3D scanning. So I would like to share one of the case studies. So we have developed the recent project with the village steel plants. So is the crossover gearbox. We have designed it for the reverse engineering for the village steel plants. So in stepwise, I will explain you. The first stage is the detailed discussion on all the spare parts and noting the bearing details of gearbox. See, reverse engineering is a very simple process, but at the same time, it's a part of experience one. People don't have experience, your reverse engineering product might get failed. So in the every stages of reverse engineering, we have to put on our experience in it. So before going for the scanning and or sort of things, we have to put detailed discussion about these products. This is the gearbox, then is the functionality sort of discussion we have to take it on the record. Then all the bearing numbers we have to note down. So this is the first stage of reverse engineering. This is the actual gearbox we have developed it. Then second stage is of 3D scanning of all the spare part of the gearbox. So this is the 4-stage gearbox. We have scanned it. Almost we are working with the take more than 30 parts scanned in 8 hours only. So while scanning also, once we need a experience. If anybody have not experience in the scanning or handling the machines, the data might maybe captured will be disturbance, because proper handling the machine is a very crucial part of the reverse engineering. Then second part is the processing 3D scan data. The data we have captured by the scanner will be in the form of point cloud. So from point cloud, though they has everything, every information in it, but we can't extract the dimensions from the uh, point cloud data. So from point cloud data, we have to process it into the STL files. So this is the STL file process. Then from the STL file, we use the Creo to create a proper CAD model. The experience is also involved in it, because we have to never miss any planes, or the modeling should be in line with the dimension we have, scan data we have to capture. Any deviation with the scan data will lead to the failure of your reverse engineering. So by making every model in the CAD, we have to assemble it. So next image will show you the assembly of that gearbox. Then after assembling and the making the CAD models, see basically we don't have to put any loopholes in our design. Once we release the design and product get manufactured, it should be at par with the or the in line with the requirement client have. If any mistakes in it lead to failure, so we have to, like for gearbox, we have to make it sure that we have to back end make the calculations also. Just like we have to on the basis of the in case of gearbox, we have to make the central distance as a parameter, and then we have to make the calculations for modules, teeth, pressure, angles. This sort of calculation we have to do it to so that we can confident that our product we have modeled is in line with the industry's standard. So after that, we have to go for optimization if required. Sometimes maybe, sometimes may not be. In the case of that, this gearbox, we find that after making the 3D model and assembly, the center distance of the bearings are varying, immensely varying from 4 mm to 20 mm. So we find that the life cycle of that gearbox will affect in the terms of spare parts and bearing. So we have to make sure that that should be in line with the industry standards and industry experience. So just like we find that uh, as I told you, this is the 4-stage gearbox. For stage one, is dimension is 312. For stage two is 310. For stage three is 304 mm, and for stage four it is 300 mm. So based on our experience and standard practices, we make them all are available in the 320. So that will help us, our client, so that this work in a proper way. So after optimizing the gearbox, we have to go for the manufacturing, releasing the manufacturing drive. Releasing manufacturing drives will be make sure that all the tolerances, all the fits you have to mention. And apart from that, every drawing has need to be go for the manufacturing. So manufacturing process will be strictly mentioned in the drawings, just like forging, tooth profiles, and all the sort of things we have to make sure. So that when the client go for the manufacturing of the same, that manufacturing of the drawings, apart from its dimension, should be follow the process of manufacturing. So this is the very small success stories. So conclusion of the means what is the case studies show that it helps apart from manual measurements and manual reverse engineering. If you go for the 3D scanning, the total times for scanning is almost 6 hours for more than 30 spares. If the same case will to be happen with the work of the manual measurement, it might take 10 to 12 days to capture the dimensions by sketching. Then second step, we will have STL file preparation is nearly for 20 hours for more than 30 steps. And for parametric modeling using PO, it will take 80 hours. And for 2D final manufacturing drawings, it will take 40 hours. And the cost saving by the industries by reverse engineering this gearbox is almost more than 30%. So this is the techniques recently used in every industries, because most of the industries, as I told you earlier, in India, machines are deployed from the overseas, and when we can call for the spare parts, it will cost the more. Also, the lead time of the spare parts to arrive at your place is also high, and in most of the cases, the lines used or plants used are running are of the more than 30 years age, and still they are running, and getting their spare parts of the same means that lines in overseas is absolute, so it's very difficult. So in India, there is huge scope of reverse engineering. So most of the countries in applying adopting reverse engineering. China is widely adopting the reverse engineering, is leading all over the world. Countries like Japan and India also utilize reverse engineering in terms of automotive. In India, most of the reverse engineering is done in field of automotive only, and huge scope of other industries like cement, steel, aluminum are still have lagging behind. The challenge is reverse engineering in India. As I told that the reverse engineering is the process of re-engineering or creating the accurate parts. So complexity of designs in many products, they are highly complex, even involve intricate design and advanced material. Sometimes India is having the lack of resources and cost. So reverse engineering any critical spares require the experienced resource, and it's also cost you more. Also the equipments and the time taken will be more, and some of the materials are may not be available, or the manufacturing process in India have some limitations. We will find is difficult locating the proper vendors. These are the processes. Then technological limitations also there. Intellectual property rights also is concerned, because how the way we are importing the machines and what are the our agreements, this depends upon that. Also, I told you earlier, high cost and high resources also is a problem. So this is from my side, and I appreciate if you have any more questions from the participant attendee. Hello.
Thank you, Saul sir. The participants, any participant want to ask any question? Dr. Murugarajan sir, do you want to ask? Yes, Murugarajan sir, you can unmute yourself and you can ask question. Murugarajan sir, can you ask?
Yeah, please feel free to ask me, because I am from the total industry backgrounds, so don't have much more practices in giving lectures. So I
No, sir,
might miss something.
this was wonderful, sir. You really shared the practical things. What is happening? What is just going on the industry? This is the good thing, sir. So your lecture was wonderful, actually.
Thank you, sir.
Yes. Actually, nobody, actually in the other lectures, what happened? The theory part are there, but nobody tells about the what is going on the industries. What is really happening in the industry? What is the exactly need of the industry? That was just told by you only, or you people like you only, the industry personals who are engaged in the industry only. So this is really a fantastic lecture or the knowledge sharing thing.
Thank you. I just tried it my best.
No, no, sir, it's a good thing, sir, and I really appreciate your efforts, sir, towards presenting these things in a proper manner.
Because I expecting some questions so that I can clarify or
Yes.
clarify your doubts
Asu,
or
sir, do you want to ask anything? Asu, sir, please unmute yourself or you can ask.
Hello,
yes, sir.
am I audible, sir?
Yes, sir. Yes, sir. Please.
Yeah. Just it's a general question about equipment industry and reverse engineering. That is commendable job that you have been doing since I think 10, 15 years,
Yeah, 22, almost 25 years, sir.
almost 25 years. For your information, I also did in the same year, 1998 only I completed my engineering,
Okay.
and I have been to Pune several times.
Okay.
I worked there also in this one. So my question was, how do you think that this reverse engineering field in India is going
Okay.
to prosper, or or you think that so many bigger companies they are putting money into R&D, and therefore the reverse engineering field will go down? Thank you.
Sir, see, basically, I choose topic of Indian industries. I clearly mentioned that my focus is on the cement, steel, power, this industry. Forget about the automotive. Automotive, aerospace have their setup only. See, but in the industries like cement, steel, power, they are concentrating on their productions. They are doing R&D about their quality of product, not for the reverse engineering sort of things. So they have huge potentials in India because see, every time technology changes, we have to go for the new technology. The plant may be upgraded, the new machines come, and same scenario when it come for the to be make in the competitive age. So we have to cut down our maintenance costs and spare costs. So
Hmm.
reverse engineering has huge scope in India.
Yes, you're right, sir.
Anybody else? Murugaran, sir, you have raised your hand. I have allowed to you speak. Any participant, please raise your hand. Saul, sir, I think no participant want to ask any more question. So, sir, I
Okay.
would like to again thanks you for your valuable experience sharing. And this is really a wonderful presentation. And surely, sir, we will again invite you for the further any FDP like this. So thank you on the behalf of Vijindal University, sir, for
Okay,
joining
thank you,
us.
Saroj sir, for inviting me. At any point of time, if you need my help, I
Yes,
will be glad if you. We will have a session with the students also. So
yes,
we are
yes,
going
yes.
to talk.
Yes,
So
surely, sir, surely.
uh, so we'll be in touch. And thanks. Sir. Okay.
Thank you so
Okay.
much, sir.
Okay. Thank you.
Yes, sir. Sir, you can exit, sir.
Okay.
Yes.
major lab 002 dash 15 major lab 002 dash 15
Dear participant, we have sent the feedback link in the WhatsApp group also. Please, from the WhatsApp group, you can post your feedback. Thank you.